Hello everyone, it's Mrs. Dubois. How you doing today? We have exciting news. We are now in Unit 2. Okay, in the beginning of Unit 2 in these notes, we're going to demonstrate how to use our algebra tiles to represent equations. So I'm just going to start at the beginning. Whoops. Okay, 2 rectangles, 2x plus 4. Then 3x plus 1. I have to make this larger, or I will not have room. And you don't have to solve them. I'm actually going to go back. Can I go back? A little technical difficulty there. It looks so small. That's 3x plus 1 equals 5. This is x plus 6 equals 2x, 1, 2, 3, 4, 5, plus 5. Then we have 3x plus 3 and x plus 2, 3, 4. Again, we're not solving, we're just representing. This is the distributive property, right? 1 group, 2 groups, 3 groups. 3 groups of x plus 2. 1, 2, 3, 4, 5 equals 5. Again, here's another one that has the distributive property. So it's 2 groups of 2x plus 1 equals x plus 4. So that's how you would use algebra tiles to represent equations. Let's go fishing. All right, fish population. Verbal. We begin with 800 fish in the pond and add 10 fish each week. You want to determine when you have a total of 1,000 fish. Remember, this is like the storybooks. Okay. You want to decide where's the begin value. All right, so you begin with 800 fish. And then what's varying or increasing? 10x. Sorry. And I should follow what it says right here about W being weeks. So that should be 800 plus 10 weeks. 10W, sorry. Equals a total of 1,000 fish. And then we can solve that. Draw a line. 10W equals 200. And W equals 20. 20 weeks. It's page 1. Okay, now we're going to collect books. Same thing, we're going to look for that begin value and then what varies. We have 50 books on our bookshelf. If we add 10 books each month, we will have a total of 120 books. So we begin with 50. And then it's increasing by 10 each month. Looking at my variable, 10m equals 120. Solve that out. You'll get 10m equals 70. M is equal to 7 months. Take 7 months to balance this scale. All right, your savings account. We start with 1,000 in our bank account and take out 30 each week. We want to determine when we will have 750 left. So algebraically, we begin with 1,000. 30x, because x is the number of weeks. Oh, take out, sorry. Oh, plot twist. So that's a minus 30. Because I don't know why I can't. I'm having trouble erasing that. Oh yeah, that was not helpful. All right, so let me just cross that off. It's 1,000, take out 30, minus 30x equals 730. And we'll subtract 1,000 from each side. 730 minus 1,000. Divided by 30. is 9. 9 weeks. All right, the temperature at 6 a.m. is -4 degrees. The temperature is increasing to 2 degrees each hour. We want to determine the temperature will reach 10. So at 6 a.m. or the beginning, it's negative, so -4. And it is fluctuating or increasing. You can look for the word per. That will tell you where the variable will go. And so it's increasing, so it's positive 2 degrees each hour. And then when it reaches 10 degrees, so 7 hours, we would add 14. Yeah. Moving along. Page 3. Okay. Here's what it looks like when you have, here's what solving equations and things we have done on the past quiz look like when you are on the MCAS. So this is 2/3 times W plus 3 equals 7. First thing I can do is I can multiply by the reciprocal. So these cancel. That's 1. 21 over 2. So then we have, I'm going to draw a line, -3. Oh, sorry, it's kind of messy. W equals, so this is like 10.5, so 7.5. 10.5 minus 3. Let me circle that so you know what's happening. All right, so the answer here is 7.5. I'm going to bloat this one a little and do it in a different color. Okay, so this is the cube root. So what number times itself 3 times equals 27? Which of the following makes this true? So the only one that makes this true is A, because 3 times 3 times 3 equals 27. What is the value of x in this equation? All right, so you want to solve an equation. You want to draw a line, distribute, then combine like terms. Start with the smaller one. -10. Add 14. So 2. Yeah, actually if you plug it back in, that makes 0 equals 0. So that works. Page 4. Sorry. I didn't even know how to. There we go. Undo. All right, these questions have 4 parts. Consider the equation. What is the solution to the equation? Show or explain how you got your answer. Okay, so if I write this equation down, I'm going to show you. I'm going to draw my line. I'm going to add 4 to each side. So add 4 to each side. X is 20. Write a linear equation in one variable that has infinitely many solutions. Show the process of supplying the equation to prove that it has infinitely many solutions. So here, this has one solution. Right, x is equal to 20. This is one solution. And if we think about it, right, if we have this equation, x equals x, x could be any number. Or we could have, like, I'm going to use a different color. 2x equals 2x. Anything where it has on the same side. Sometimes you can get fancy. I'll put like 2x plus 6 equals 2x plus 12. But any one of these three, A, B, or C, would give you many solutions. X could be any number or many solutions. Okay, now consider the equation. How many solutions does this equation have? I just like to solve them best. So I have to rewrite it. 3, 4 plus x draw a line. 12 plus 3x equals 7x minus 4x minus 6. Combine like terms. This is 3x minus 6. Okay. Now, we subtract the x's. If I subtract 3x from each side, I'm going to get 12 is equal to negative 6, and that is a false statement. So that is no solution. Remember at the beginning we talked about what makes it true and what makes it false. And so that is a false statement, so there's no solution. And then how many solutions does this have? So 3, 8x minus 6 x minus 6 equals 2 minus 1/2 x. Whoosh, getting sticky here. Now, I like to get the variables on one side. So I would add 1/2 x. So that would be 7/8. Nope, sorry. Oof, the whole erasing thing again. Oh yeah, that would be true. That would be true. Because this would be 1/2 is 4/8. So it would be 7/8 x equals add 6. That would be 8. So we'd get one answer. And you can keep solving it. And divide by 7. So one answer, one solution. And I feel like I've made a mess of things. The fruit stand sells oranges, bananas. The cost of one apple is 50 cents. The cost of one orange is 60 cents. I think I'm going to stop it right here and let you solve number 5. And then when I collect it, I'll see how well you did. All right, so the moral of the story is you want to make sure, so you want to finish number 5. And you want to make sure that when you're solving equations, you're keeping in the back of your mind that they can have one solution, many, or none. Okay. That concludes the set of notes.